Welcome back. This is the second part of trig ratios, and when we're doing this next part, we are going to end up solving for the leg lengths or the hypotenuse lengths in triangles. So we're going to use trig ratios to set up a formula like we did in last section in order to solve for the lengths of triangles. Let's take a note about the hypotenuse. The hypotenuse, as you remember, is always the longest side. It's always the longest side of a right triangle. And so when it's on the bottom of a fraction, and you put either the opposite or the adjacent side, it's going to be a fraction less than 1. Because think about it, if the hypotenuse is 7, the numerator is always going to be less than that because the hypotenuse is the longest side. And so the fraction is going to be something like 6 over 7, or 5 over 6, or 7 over 13. And so that's going to give us something with a number value that is less than 1, so a decimal. So sine and cosine are decimals less than 1. Okay? Now, in example 4, let's set up a couple of equations to solve for the length of a side. The key to this, finding lengths, set up an equation. Set up an equation. Set up an equation. Set up an equation, set up an equation. Because when you set up an equation, you're giving yourself the maximum number of possibilities to solve for. If we're going to solve for AB, we need to see how things relate. I'm going to go ahead and put x here because that's going to give me a variable that represents AB. I want to think about what I have. Right now, the least amount of work would be to use 41. I notice that AB is adjacent to 41 degrees. It's adjacent to it. We also have 6.1, which is the side opposite 41. If you look at the two key words I've used here, adjacent and opposite. Which trig ratio do you think we're going to use? I'll give you a hint. Here is my mnemonic. SOHCAHTOA. So we look to see which one of these three ratios involve the opposite and the adjacent. It's got to be tangent. So here's what I'm going to set up. The tangent of 41 equals, I always take the tangent of an angle. You take the tangent of degrees. You take the tangent of an angle. So when I say tangent of 41, it's equal to the opposite over the adjacent which is equal to 6.1 over x. Notice, I've got tangent of 41, I have 6.1, and I have x. I have an equation with one variable. This is really good for us, because if we have an equation with one variable, we can solve that. You're thinking to yourself, but what is the tangent of 41? Calculator, hello. Okay, we want to try to avoid rounding until the end. So, what I'm going to do is I'm going to solve for x. Watch how I do this. Multiply by x on both sides. And what that gives me is x tangent 41 equals 6.1. I wanted to get x out of the denominator. That's good. Then I will divide by tangent 41 on both sides. Because remember, tangent 41 is just a decimal. I just don't want to round it yet. So x is equal to 6.1 divided by tangent of 41. Let's put it into our calculator. 6.1 divided by, and I'm going to put parentheses, so this is going to be 6.1 divided by, this is what it looks like in your calculator, tangent 41. I put it into my calculator using parentheses, and I get 7.017, so I'll round, equals 7.02. I didn't round until the end. Don't 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 tell me what tangent of 41 is as a decimal. Just divide by tangent 41. It gives you a more precise answer. Okay? So, when we divide by the tangent of 41, we get 7.02. Let's look at another example, because that can be confusing the first time around. I understand that. I get it. Keys. Don't round till the end. Another key. Set up an equation. Alright, we set up an equation, we don't round to the end, we should be good to go. Let's look at what we've got. MP, I'm going to make that x again, and I'm going to look at what I have. I have this 20-degree angle here, and I have the hypotenuse, my spelling's a little suspect this morning. I have the hypotenuse, which is 8.7. I need the side opposite 20. If I have hypotenuse and I need opposite, if I look to my SOHCAHTOA, which one involves opposite and hypotenuse? Hello, sine. Sine of 20 equals opposite, which is x, over hypotenuse, 8.7. Don't round to the end. 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 Let's solve for x. Multiply both sides by 8.7. So I have 8.7 sine of 20 equals x. That looks like something I can put into my calculator. Okay? Here's what I'm going to put in. 8.7 sine 20, and then hit enter. 8.7 sine 20. Can you see that? You probably can't. It's for effect though. 8.7 sine 20 gives me 2.975. So I'm going to round to 2.98 because I did not round to the end. Remember, your calculator needs to be in degree mode because we're dealing with degrees. So, degree mode is key. 2.98. Let's do one more. See if I can separate these problems a little bit. I'll keep my SOHCAHTOA on hand because I have a feeling I'm going to use it. What do I have? I have this 38-degree angle. I also have the side adjacent to it. $12.6. What do I need? I need YZ. Need YZ, which just happens to be the hypotenuse. Don't know how they came up with that word. Let's look at what we've got. Have adjacent. Need hypotenuse. I don't know if you've been noticing what we've been doing. We're using the ratio that we have something that we need in it. So let's look. Which one involves adjacent and hypotenuse? Not sine, not tangent. It must be cosine. Cosine. We always take the cosine of an angle. Cosine of 38. The cosine of 38 is equal to the side adjacent to it, which we have because we decided that we had that, which is 12.6, over the hypotenuse, which we don't have, which is good for us because we'll call it x, and that's x. Notice this looks exactly like the first one that we did, except that we're using cosine. So we need to solve for x by multiplying by x on both sides. X goes away. Look at what I've got. X cosine 38 equals 12.6. And guess what? I'm not rounding to the end. Don't round to the end. Don't round until the end. I will divide by cosine 38. So therefore, x equals 12.6 divided by cosine of 38. Forgot to divide by cosine 38 on both sides. This looks like something I could put into my calculator, so I'm going to type it in as 12.6 divided by parentheses cosine 38, and there's parentheses around that too, so I close them both. 12.6 divided by cosine 38 equals 15.98999. You see how this works? Set up an equation, don't round till the end. Set up an equation and don't round till the end. Set up an equation and don't round till the end. Guess what? Set up an equation and don't round until the end. You should be fine if you remember that we're using the trig ratios. I've got 3 problems for you. Alright? I'm going to scroll through them and pause on each one of them. Make sure you write them down. Try them. Guys, you got to try them, because if you don't try them, then you won't have the practice to know how to do it. Try them. Try them. Try them. Here we go. Here's the first 2. We're going to be looking for DF. Here's a hint. DF is the hypotenuse, and you have the opposite side. Opposite hypotenuse sounds like sine to me. In E, we're finding ST. Well, ST just happens to be a leg. It happens to be the leg that's adjacent to 42. We also have the hypotenuse. Adjacent and hypotenuse. Sounds like cosine to me. The third one. Oh, you got a bonus one for BC. We're finding BC. BC looks like a leg. Looks like an adjacent leg to the 18 that we have. Guess what? We have the adjacent leg that we're looking for, and we have the opposite leg of 12 feet. Opposite and adjacent. Sounds like, you guessed it, tangent. JL, I'm going to leave you on your own for that one. So, I've given you a hint on all 3 of those. Please try them. Please try them. Please try them. Said it 3 times. Must happen. It's going to help you. Thanks for watching, guys. We'll catch up with you next time.